we say that this is calculus. Okay, it is a branch of mathematics that deal with the study of change, motion, rate, rate of change, area and volume, right? So that is our calculus. So we have majorly types of calculus. Okay, so majorly we have from our figure 1 to be differential calculus. Okay, so this is number 1 type of calculus. Under differential calculus we observe the study of derivative, okay, or derivation. Okay, gradients, we study gradients, and also the rates of change and the slope. Okay, the slope of curve, right? So these are inclusions of differential calculus. We do normally make use of our differential calculus in different subject matters, subjects like physics, subjects like economics, and other engineering subjects. Is that taken? So this is our model or templates, right, of our differential calculus. We have if we have something like this, maybe we have 2x power 3. Is that taken? And the interpretation of this is this. This is we can make use of our n times a power n minus 1. Is that taken? Now take a look at this right up. I didn't mean that we are given this as our question. We have 2x power 3. We are now asked to look for the derivation of this. What we are going to do is this. This is the normal process. This our 2x represents our a. 2x represents our a. Is that taken? So our power, which is 3, represents our n. Is that taken? So I can rewrite this to be let me do it this way. I can rewrite this to be a power n. Is that taken? So this tells that our 2x is a and our 3 is n. Do you understand? Our 2x is a and our 3 is n. So you can further simplify it this way. Is that taken? So that is how it is. And we do normally make use of our dy dx depending on the variable given to us, right? So if you are given two variables such as y and x, you are going to use dy dx. But if you are given a and b, you are going to use dA all over dB. Is that okay? Let's just take for instance, this is example, okay? This is example, right? So I didn't mean that we are given 3x power 2, okay? Therefore, dy dx is going to be, you will use this, that I said that this our 3x represent this our a, and these 2 represent this our n, right? You will now further proceed. You now say that your power, which is 2, you will use to multiply this n, unlike what I wrote here. Is that taken? You use a power which is 2, that is our n, you use to multiply this x, this 3. Is that taken? So we have our 2 times 3, okay? We have open brackets x, and we now have power 2 minus 1. So the end result of this is going to give us 6x power 1. This is the derivation. Is that taken? After going through the process of this our dy and the x. Is that taken? So, and if you are also given this, maybe this is our example 1, we can use this as our example 2. We have 4r, power 4, right? You are now asked to find the derivation of this. In actual sense, like what I said, they are going to write our dy dr, because we are given r, is that taken? So it will be 4 times 4. This is 16 r. 4 minus, this is 4 minus 1 is going to be 16 r power 3. This will be the final answer. Is that taken? So let's observe one more example. Adding being that you are given your p is equal to 6g power 4, okay, plus 2g power 3, okay, so plus 4g, all right, so power 2 minus 3g. So for you to differentiate this, the derivation of this, it is this. So you are going to write, it is not the y ds this time around. You are going to write the p all over the g, because you are dealing with two variables, p and g. Is that taken? Then you now follow this process and you will get it right. Am I communicating? So in actual sense, we can say that our 4 times 6 is going to give us 24g. 4 minus 1, 3, plus 3 times 2, 6g, and we now have 3 minus 1, that is 2, plus 2 times 4, 8 times g, that is 8g, 2 minus 1, that is 1. You didn't need to put a 1 there, minus, this is, there is an invisible 1 here, 1 times this 3 is going to give you 3, okay? So this is the final answer. And of course we have our 1 minus 1, the power, which is 0. So there is g power 0, and anything raised to power 0 is 1. So therefore 1 times 3 is to give you 3. So this is your final answer for this question, Roman figure 3. Is that taken? So this is illustration 3. Am I communicating? So that is it for our differential calculus. Is that taken? So we now proceed to type 2, which is integral. This is integral calculus. Okay, so for our integral calculus, you know, it is a branch of calculus or side of calculus that actually discuss about our curve. We have inclusions like curve, okay, we have curve, and then we also have accumulations and equations. We have accumulations, okay, and equations. So all these are inclusions of our integral calculus. Am I communicating? So for our integral calculus, I'm going to make use of this process as well. Now I didn't mean that you are given this, you know, you need to follow process. I didn't mean that you are giving maybe x power 3. Am I communicating? Now in actual sense, don't forget what I said, that this our x power 3, that is our x represents our a, and this 3 represents our n, going by what I said when I was discussing about differential calculus. Am I communicating? So we have it this way, so therefore we can have our model. We are going to write our model this way. This is the template that we are to follow when discussing about or when addressing our integral calculus. So therefore we have our a, okay, we have our